Hi, myself Dr. Kavita CV. In this session, you are going to learn about alkaloids. Definition, classification based on heterocyclic rings, isolation, synthesis and structural elucidation of nicotine. Okay, alkaloids meaning alkali like means these compounds are basic in nature. They contain one or more nitrogen heterocyclic rings, and these compounds occur in plants and they exert pronounced physiological action. Moreover, many of these alkaloids are important drugs. Based on all these facts, you can define alkaloids are plant produced basic compounds which contain one or more nitrogen heterocyclic rings and can cause marked physiological activity in humans. Even though this definition covers large majority of alkaloids, it is not perfect. The reason is, first one, piperine. The alkaloid of pepper is neither basic nor does it produce any physiological effect. Got it? Second one, caffeine, a nitrogen heterocycle, a heart stimulant and a diuretic, but it is not considered as an alkaloid. Third one, alkaloid. Marijuana contains no nitrogen. Then fourth example, ephedrine is an open chain alkaloid. Okay, so these are some examples. Classification. Based on the prominent heterocyclic rings present in the molecule, they are classified into different classes. First one, pyridine alkaloid. Example, nicotine. See the structure of the nicotine. It contains pyridine as a heterocyclic ring. That is the prominent heterocyclic ring. Next, piperidine alkaloid. Example, conine, piperine. You can see the structure here. Then third one, quinoline alkaloids. Example, quinine. Fourth one, isoquinoline alkaloids. Example, papaverine, morphine, etc. You can see the structure. Then fifth one, indole alkaloids. Example, gramine, strychnine. See, strychnine is a complex molecule. Alkaloids are mainly present in plants of dicotyledonous family and are localized in seeds, leaves, bark or roots of the plant. They are generally found as salts of oxalic acid, citric acid or tartaric acid. See, the powdered plant material is first digested with water and then acidified with HCl. The mineral acid liberates the alkaloid from their salts with plant acids and convert them into hydrochlorides. The aqueous layer containing the hydrochlorides of alkaloids and the soluble plant impurities is then treated with base. The insoluble alkaloids that are set free precipitate out. The solid mass so obtained is extracted with ether. So all the alkaloids present in that part will be passed into the solution and impurities left behind. The ether extract is evaporated to get alkaloids. And these alkaloids are generally colorless crystalline solids. Very few are liquid. Example, nicotine, conine. And they are insoluble in water but soluble in organic solvents like ethanol, ether, chloroform, etc. And this compound, as I said earlier, they induce marked physiological activity in humans. Most of them have intensely bitter taste and are poisonous, and they are optically active, and majority of them are being levorotatory. Okay, and they give reactions of cyclic amines. Next, synthesis and structural elucidation of nicotine. Nicotine, you know the structure. It is a pyridine alkaloid. It occurs to the extent of 2 to 8% in dried leaves of tobacco plant. In small doses, it stimulates the nervous system for a while. That's why smokers crave for it via cigar or pipes. So, but in large doses, it can cause depression, respiratory paralysis and finally it leads to death. It kills insects on contact, so it is used in sprays against leaf-sucking pests. So structural elucidation, you know that first point we should know what is the molecular formula. So based on elemental analysis and molecular weight determination, the molecular formula of nicotine is found to be C10H14N2. There are two nitrogen. So we should know the nature of these nitrogen. So the presence of two nitrogen atoms. When treated with methyl iodide, it forms dimeth iodide, showing that both the nitrogen atoms of the nicotine are tertiary in nature. Got it? See the equation. So nitrogen, there are two nitrogen, both of them are tertiary in nature. Then presence of pyridine ring. On oxidation with chromic acid or nitric acid, nicotine gives nicotinic acid. So the structure is pyridine 3-carboxylic acid. This shows that there is a presence of pyridine ring in the nicotine and there is some ring attached at position 3. This shows that nicotine contains a pyridine ring with a side chain having the molecular formula C5H10N. Based on this, the formula of nicotine may be written as like this. Okay, see the structure here. Pyridine ring at third position, molecular formula C5H10N. Then, what is the structure of side chain? For that, nicotine zinc chloride complex on distillation with lime gives pyridine, pyrrole and methylamine. This shows that there is a presence of pyrrole ring in the nicotine. When heated with concentrated hydroiodic acid at 200 to 300 degrees centigrade, nicotine forms methyl iodide. This proves that CH3 group in the side chain is attached to nitrogen atom. See the equation. To account for the side chain, it may be written as N-methyl pyrrolidine group. See the numbering of the pyrrolidine ring. So next question, whether second position of the pyrrolidine is attached to pyridine or third position is attached. For that, nicotine is treated with methyl iodide and forms nicotine isometh iodide, which on oxidation with potassium ferricyanide yields nicotone. Nicotone on oxidation with chromium trioxide gives igrinic acid. This is the structure of igrinic acid. So based on these facts or the experiments, the structural formula of nicotine can be considered as like this. See, the structure of the nicotine is confirmed by its synthesis. For the synthesis of nicotine, the starting material is nicotinonitrile. So it is treated with some Grignard reagent to form the compound like this with the keto group. Then keto group is converted into oxime. Then it is converted into amine. Then the ethoxy group is converted into Br by treating with HBr at 150 to 155 degrees centigrade. Then it undergoes cyclization. Then it is methylated by using methyl iodide to get mixture of nicotine, that is plus and minus. Then finally the product was resolved by means of plus tartaric acid and the synthetic minus nicotine means levorotatory nicotine was found to be identical with the natural alkaloid. Okay, got it? For the more information you refer these textbooks. Thank you.